Okay, let us move forward. The next step is how the arbitration works. I told that when more than one node is trying to transmit at the same time, as per the standard, it should allow the node to transmit if the bus is free. But as per the serial communication, because it is going like a pulse, one pulse after another pulse, one bit after one bit, it is like the serial of series of bits, right? It's a train of bits going one after another. But it goes like a voltage pulses as a PWM waveform. If that is the case, how to assign the priority, how the CAN handles that? We are going to study that. The priority of message is who is the winner. The winner is decided based on their ID, based on the value that they have in the ID. And then they use an operation called AND function. All of us have studied about AND gate in the digital logic. What is the characteristic of AND gate? AND gate will produce high output when both the input are high. If any one input is low, it will produce the low output. Correct or not? You may have 5 inputs or 10 inputs, not at all a problem. If among those 10 inputs, if any one fails, the system will fail. That means it will give an output, low output. If all your 10 signals are high, then only you will get a high. That is what the AND gate. That logic is used to find out the priority of the messages. Let me explain you with one example so that you will understand. Okay. First, so I believe yesterday I draw a diagram. Let me redraw it again. See, this is my first node. This is my second node. This is my third node. And then I have a bus here. I have another bus here. And then they are terminated with 120 ohm resistance. This is my first ECU. Let me call that as ECU1. This is ECU2. And this is ECU3. This one has messages 34, 0x, 89, 0x, 67. This is like 0x, 98, 0x10, 0x 668, 0x 35, 0x 56, 0x 29. Okay. These are the 3 ECUs. Now the bus is free. Bus is free means the bus is kept in the voltage level of 2.5 volt. That will be considered as a bus free. That means there is no voltage fluctuation in the bus, so that every node has a right to transmit. They are going to transmit. This is the Q. The Q means usually The queue is nothing but arrangement of messages in a buffer. It is similar to the queue that we go for when we want to buy. The best place that you can see the queue in our city or village is like in ration shop and then in railway station. So everywhere we used to see queue, no, the same queue, but it is in digital queue. In that queue, these three messages in this issue, these messages are arranged one after another. The same way, in this issue, these three messages are arranged. Here, issue 3 has three messages. Don't think that among these three messages, whichever is the very lowest, whichever is the lowest, in this case 34. 34 will be transmitted. Among these three, the 10 is the one, so it will jump this message and will come. No, not like that. Whoever is in the top, though whether it is lower identifier or higher identifier, whichever is the top of the queue, no, that only will go to the bus when the bus is free. Here it is 34, here is it in 98, here is it 35. Now the arbitration should happen only to these three messages, not for all messages or not like only the least messages, something like that. Those things are not correct. Actually, whoever is in the top of the queue among in those messages only arbitration will happen. Particularly the identifier, on the identifier of the message, the arbitration will happen. Okay. Now what I am going to do, I am going to convert these three IDs into equivalent binary because that digital logic will work in binary. I am going to convert that. For that, I need a notepad. Let me bring a note. Right. 34, I changed it to 11 bits because the standard CAN used to have 11-bit identifier. Is it correct? I say this as 34. Is that correct?
Yeah, it's correct.
How?
Yeah, 84. Okay, so if you take the 3, second, and 2 plus 1.
Okay, actually, it is okay. It is very simple. This is an X number only. So 4 bits are equivalent to 1 nibble. In digital electronics, 4 bits are equivalent to 1 nibble. So the 34 that we have, the 4 can be written in binary as 0, 1, 0, 1, 0. 1, 0 is equivalent to 4. In order to write 1 nibble, I need 4 bits so that I am padding a 0 with that. I am getting 0, 1, 0, 0. That is 4. Again, for 3, in binary, 1, 1 is equal to 3. So, but in order to frame a nibble, I need 2 more bits. I am padding 0 in front of that. That doesn't have any value. So, I am just padding 0, 0, 0, 0, 0, 1, 1. So, the 1, 1 is 3, 1, 0, is 4. That is what? 34. But total bits of standard CAN is 11 bits. But I'm able to cover that in only some 6 bits. I'm able to do that. But remaining bits, what happened? So I simply put 0 there. That's why I'm getting this value. Do you understand that or not? All of you, I'm asking.
Sir, I followed a different logic. Yeah, like 8421 kind of thing I followed, sir.
No, yeah, everything is same. At the end, the easiest way, why they brought this logic is in order to convert, usually hexadecimal number, to convert that into binary is very, very easy. If you know the equivalent binary of every digit, I know the equivalent binary of 4 is 100 and 3 is 0 double 1, otherwise 1 1. So as I know that, I'm able to put that, because you should not get confusion. That's why I'm explaining this. The equivalent, I'm just getting the binary equivalent of these IDs. Okay, 34. Again, 98 can be written like this. How we can write? So first 3 bits 0 0, and then 1 0 0 1 is equivalent to 9, right? And then 8 1 0 0. Then for 35, it is 0 0 0, and 3 can be written like 0 0 1 1, and then for 5 0 1 0 1. Correct? Okay.
Correct, sir.
When you see the frame structure, after start of frame, the immediate bits that you will see in a CAN packet is your ID values. Let me show you a CAN frame, so how it looks like, and then what we have. Actually, this is a CAN frame. This is a CAN frame. See, after the starter frame is a low, active low, 0. After that, what you have, the 11 bits are nothing but your ID value, identifier value. While they are transmitting, they won't transmit the LSB first, the LSB of ID first. For example, if you take this ECU1, this one is the LSB. But while it is going out in the bus, they will start from the MSB. So MSB will only will move out. That is how the frame has been framed. Like that is a message has been framed after start of frame, first MSB bit. Like that, after that, it used to go. When after start of frame, everybody start of frame is active low. Everybody used to have active low. They are all equal. There is no winner as of now. So they will go for next level of fighting. It is something similar to chess. So initially they will go step by step. Everybody gives 1 1 0 0 0. So there is no winner. They go for second step. Second step is they will push their MSB bit out. This guy is pushing 0. He is also pushing 0. He is also pushing 0. But all are equal because every node is pushed only zeros. The bus value also will be dominant. When all the inputs are low, this one also low. What will happen? They will go for a second round. They will push next bit. This ECU will push this 0, and this one will push this 0, and then this one will push 0. Again, they are equal. They will go for next level of fighting. Again, they will push this. This ECU will push this, and this ECU will push this. No winner. Again, they are going here, but this one push is 0 but this one is having 1. This one is having 0. This one is having 1, and this one is having 0. What will happen when you have 1? That's all. You have to wait. You lost the bus. Why? When we end 0 1 0, the result is 0. Why? Because AND operation will give high output only when all inputs are high. Then only we will get high output. As the low is, this one also having low, this one also having low, this one having higher, it will lose the bus because his voice is not here, because these two guys are dominating the bus using their 0. Because of that, what will happen? This one will lose the bus. This issue will lose the bus. It will wait. Then what we have? We have only these two, right? They will go because both of them have 0. They have to do the next level of fighting. This is also having 0. This one also having 0. What will happen? Both are having equal things. Again, they will fight. Again, this one is having 1. This one also having 1. There is no winner. They will push their next bit. This one is having 1. This one is having 1. There is no winner. Next, this one having 0, and this one is also having 0. Equal. there is no winner. Again, this one is having 1 and this one is also having 1 equal. They will still do the fighting. But this one is having 0. This one is also having 0. Still fight goes. But at this point, this guy has 0 and this guy has 1. So he loses the bus. So ECU3 will lose the bus at the last bit. 11th cycle, 11th comparison cycle, he will lose the bus. That is the last bit, last ground that he has to win. See, he has the hope still 10 bits shifting. He had a hopes to win, but at the end, he has won, he lost the bus. The ECU1 will complete its transmission. When ECU1 pushes his bits, others cannot do anything. They have to wait. How long they will wait? Till this one completes its transmission and its end of frame is pushed out. The moment that is over, next step is unconditionally ECU3 will go because he is in the second place. He is the second one. So he will complete the transmission. After transmission of ECU3, then the ECU2 will complete. When you see this order and also when we see this diagram, see ECU1 is that is 34 is going out first, then 35 and then 98. Is that correct or not? So initially 34 is pushing all the messages. That means its message is going first and then 35 and then 98. So when you see this, the 34 is the least number in these three numbers, like 34, 98 and 35. 34 is the least one. Once this group is sent out, next second group will come into the picture. That means 89 and 10 and then 56. The arbitration, whatever that I explained, the same process will be repeated for 89, 10 and 56. Who will win? 89, 10 and 56. Who will win? Gayatri.
Five, 6.
How?
Because lower the ID gets the higher the priority.
Right. But 10 is very least number. See, the second level, we have 89, 10 and 56, right?
Then it be 10.
Yeah, 10. Okay. Okay, after that group, who will win? 67, 668 and 29.
Sorry, 56, 29 and?
See, arbitration used to happen. First arbitration happens between 34, 98 and 35. The second arbitration happens between 89, 10 and 56. Third arbitration will happen between 67, 668 and 29. Who will win?
29.
Is that correct?
Yes.
How?
Because lower identifier having the higher priority during arbitration, and we use and logic now.
Yeah. So the 29 will go out. That is least identifier has the higher priority. Okay, initially the 29 will go out in these three messages. Next, which message will go? 67 or 668?
67.
Why? Because it is having the next least number. After
Yes.
29, we are having 67. And then finally, 668 will go. Do you guys understand how the arbitration works?
Yes.
If I have 5 nodes, arbitration will happen between how many messages? 3 messages or 5 messages?
5.
Why?
Each node will have different CAN IDs.
See, if I have 5 nodes,
Yeah.
arbitration will happen between 3 messages or 5 messages.
Based on the communication, the message which are sent on the bus.
Okay, let me tell you the scenario. This bus is free. That is the first condition.
Yeah.
And then I have 5 nodes in the bus. That is the second condition. Each node has a message, ready-made message to transmit.
Okay.
Now, arbitration will happen between how many messages?
5.
Because every node has one message. One message to send out. Arbitration will happen between 5 messages. If we have 10 issues, arbitration will happen 10 issues. But the scenario should be correct. So the bus should be free, and then you should have 10 nodes, and then everyone should have a message to transmit. Only in that time this will happen. Clear?
If on the bus we are having 10 nodes,
Okay.
and within that 5 are having messages and 5 are not having the message, what will happen?
Arbitration happen between only 5 messages. What I am saying is a maximum message that will involve in the arbitration is 10 in case of if you have 10 nodes, you will have 10, arbitration will happen between 10 messages. When you have only 5 nodes, maximum you will have arbitration will happen between 5 messages. It's purely depends on how many messages that you have. Also, all the messages should have a ready-made message. There should be a message to transfer in their hand. Okay. Clear?
Yeah. In a network, how many nodes can be available?
Okay, practically there's no limit, but auto manufacturer will go up to 32 as the maximum. That is like, because we are saying that based on the Keno limitation, in Keno you can go maximum 32 nodes. Beyond that you cannot go. We believe that that is based on standard. But as per standard, there is no limit. You cannot say like this much node or something like that. This 32 decision is made based on the practical scenario. Like they might have interface that might issue, their performance might be slightly varied. Because of that, they have that limitation. But it is not documented in the standard.
In car, we will have multiple nodes.
Yeah, you can have, but no car will have 32, 100 nodes and all. No. Every issues can have hundreds of signals, thousands of signals. That is not a problem. As a ECU, which is capable of transmitting the CAN message, that can go up to 32. That is also a practical scenario, but in theoretically, there is no limit.
If I'm having 80 ECUs means how not
If 80 node has a message to transmit, arbitration will happen between 80 messages. But practically, from my experience, I never see a car which is having 80 ECUs or something like that. That is, it's all like architect will decide like how many issues can. But I don't understand your question. I believe you want to ask some specific questions.
yeah, because in lab course they use 80 ECUs and in 70 they use then remaining 10s are will be the simulated ones. So how it will be? how
Oh, you
many
mean to, okay,
nodes will be
maybe. That's what I'm seeing. Something is a theoretical, some is a practical
Okay.
things are there. In as per standard, there is no limitation in how many nodes you can have in a channel. That is not told, like only this much of issues you can have. It's all like how many messages are there in each ECUs. If you have only one messages, totally you will have only 80 messages. One messages in one ECU means totally 8 messages, even if you have 80 nodes. It depends on your bus load and number of messages transmitted by the ECU, and then your OEM and your product, everything. That area is gray still. There is no a benchmark to say only this much of issue can be there in a network. That's all. But practically, or based on my experience, I didn't see that much of a real issue connected in a car. That is my experience. Maybe if that is the case, yes, there should be a possibility. Shall we move forward? Is this point clear to you guys about arbitration, how that works in CAN?
Yeah.
Yes. In car, we will have multiple CAN buses.
Okay, that is because why we have, there is channel 1, channel 2, like that. They used to maintain a channel. Though both the channels are operating in CAN, they are having 2 different channels. Why? Why don't we connect all the issues in one CAN channel itself, one CAN bus itself? They used to have a high speed CAN, low speed CAN, mid speed CAN. Why? Why it is so? The reason is when you have different baud rate, the ECUs cannot exchange the information. For example, I am having a ECU which is operating in 500 kbps. I do have another ECU which is using only 250 kbps. Can I connect these two in the same bus? No, I cannot connect that. Why? The baud rate mismatch will happen. It is like synchronization. He is operating in one speed and he is operating in different speed. The speed match will not happen. That's why what they used to do means all issues, otherwise those issues, those are running in same speed will be grouped together. All issues which are operating in 125 kbps will be grouped in one bus. Similar way, 250 kbps will be grouped in one, they will be grouped. Similarly, 500 kbps will be grouped. Then they will call that as, if it is a lowest speed, they will call it as LS CAN. And if it is a 250 kbps group, then they used to call a mid speed CAN. If it is a 500 kbps, they used to call it as a high speed CAN. In a CAN bus, if you have 10 nodes, all 10 nodes should operate in a same baud rate. There cannot be different baud rate. If that is so, the communication failure will happen. They cannot exchange information. You will find only error frames. That's why they have more buses. Times the people who have different standard bus, 2 CAN bus and then 1 LIN bus, 2 CAN bus, 1 most bus, 2 CAN bus, 1 FlexRay bus, like that they used to have. That is different. That is, they are used for different purposes. LIN are used for low cost. FlexRay and the most are used for the infotainment related stuff. Those are used for different purposes. That the thing that I am talking about, when you have same CAN, but you have 2 different bus. The reason behind that is this one. Every issues in a bus should have the same baud rate. Baud rate is nothing but the speed in which he is transmitting the bits out. It is a serial communication only. The speed in which he is sending out the bits, that is called as baud rate. That baud rate should be same to every issue. That's why we have more buses. It's clear now?
Yes.
This is how the arbitration works. Then this is a pictorial way of doing things. Same thing I explained via binary value. They have done it via PWM waveform because when the bits are sent out from the ECU, they will be sent like a voltage pulses. They will be like this only. When you see node 1, node 2, node 3, everybody has one message to transmit. They are transmitting their start of frame or first, see their start of frame, all of them are having the low, so the bus is also low. The second bit, all of them have 1, the bus is also 1, there is no winner. And after that, all of them having low, so bus is also low, there is no winner. After that, at this point, the node 2 is having the high value, whereas node 1 and node 3 is having the low value. As they are having low value, the bus is also going low value. Because of that, this guy is losing the bus. He is unable to transmit, but he is having 1 in his bit position, but the others are dominating him. Because of that, he is unable to transmit. He is simply waiting. Next, the fight is between these two. Again, we have 2 members. The bus can be used only 1 member at a time. They are fighting to win. The next bit for both of them is high, so there is no winner. Again, they go to the next level. There, this guy is having low, this guy is also having low. Again, there is no winner. In the next step, the node 3 is having 1 and the node 1 having 0. Because of that, he is losing because this is 0 and 1. When we add the zeros and 1, 0 will be the result. Because of that, this guy is losing the bus. Node 1 is doing the transmission. The moment he complete the transmission, next who will get the chance? Node 3, because he already crossed some limits. So he will go and complete his transmission. After transmitting the node 3, the node 1 will push his message out. So he will complete the transmission. After doing this step, the next 3 messages in the queue will be taken and the arbitration will happen among those messages. Clear? I explain it via binary. Here, the people has drawn some sort of waveforms and PWM waveform, but practically the voltage pulses are used. It will be like that only. Whatever that I explained, the binary, that is happening in the voltage level.